Chapter 9, Inheritance and Interfaces, Part 7. So, interface. This is the third definition of interface, and this is probably well, one of the one of the most important of the three. And an interface is like a class. It's very much like a class, except that it only contains abstract methods. So it's just got method headers in there. Only public abstract methods, actually. And so a class that implements the interface must implement all of the methods in the interface. That means it must define all of the methods in the interface. So it is similar to a class, but there are three key differences. All methods in the interface must be public and abstract. They have a name, parameters, and a return type, but they do not have an implementation. That means they do not have a method body. All methods in the interface are automatically public. All interface type cannot have instance variables. An interface type cannot have static methods. So just these public abstract methods. Here is a syntax definition, public interface, and then the interface name. Just like classes, interface names start with an uppercase letter. And then inside the body of the interface, the method declarations. So that's just the method headers. You leave off public and abstract because they are public and abstract by default. When we implement the interface, we say public class, class name, and then if the class extends any superclasses, if you'd put extends first, so extends superclass first, and then implements. And you can implement any number of interfaces. Typically, we just implement one, but you could implement several if you wanted to, just separating the interface names with commas. So if we look at this measurable interface, and measurable just says that it's got a method that returns a double, and it says get measure. What get measure is, that method is going to be a way to measure the current object. So each object can be measured in a different way. If we look at bank account, we say public class bank account implements measurable. How do we measure a bank account? How do we say what value it is? The balance is a very convenient way to do that for bank accounts. So we can just return balance. When we're talking about savings account, we had some debate about this in class, and I don't have an answer, but I think it's worth debating. Do we include interest rate? Do we not include interest rate? How do we measure a savings account? So implementing the measurable interface just assures that we have some way to measure that object. So we can use the interface type measurable to implement a, quote, universal static method for computing averages. It's when we say this, we're not implementing the static method for computing averages inside each of the classes. Rather, it would be in a client of these classes. So if we say public static double average measurable array OBJs, look at this, we're passing in an array of measurable references, because just like a superclass reference can reference objects of a subclass, similarly with interfaces, if we have a class that implements an interface, we can reference objects of that class with interface references. So you cannot instantiate objects of an interface, but you can create references to, of the type of that interface. So if we have an array of measurable objects, we're just saying that each one of them has that get measure method that we could call, so we can assess the value of that object. So if objs.length equals 0, return 0. Again, just like checking for null on a previous slide, if the length of the array is 0, do not go another step. Return 0 because there isn't any average as a result of this array, because there's nothing there. There's nothing to average. So when we're calculating an average, we need to sum all the values and then divide by the total number that are there. So we set up our sum, our accumulator variable, double sum equals 0. For measurable OBJ, colon OBJS, we are using the enhanced for loop. Recall with the enhanced for loop that we can't change the object while we're on it in the for loop. However, we're not modifying any objects in our measurable array. We are just accessing them using the getMeasure method. So sum equals sum plus obj.getMeasure. So we're calling the getMeasure method and summing up all of the measures. These can be disparate objects. We could have a bank account, we could have a car, we could have any other rectangle, as long as we have a way to measure it. And that will allow us to average all of them by getting that measure. And then we return sum divided by the length of the array, how many elements are in there, and that will return our average. When we implement an interface, here's an example. If we say public class bank account implements measurable, implements is a keyword and it must precede the name of the interface. And then we have to be sure that we override all the methods that are in that interface. Similarly, public class country implements measurable, and we have a way to measure the country objects. We implement getMeasure inside the country class. Here is a UML diagram. Interface in the chevrons there, the two angle brackets, reminds us that that's an interface. The interface is measurable. We use the dashed line instead of the solid line to also tell us that that is an interface. And both bank account and country implement the measurable interface. And so this is just showing that with the UML diagram, with the dashed line and then the up arrow. Note there is not an arrow on both sides of the line because measurable has no knowledge of bank account. It has no knowledge of country. It's a one-way street. Bank account knows measurable, country knows measurable, but not the other way around. Here's an example. Feel free to hit the pause button and read through this code. You can also get this code from the Student Companion website, and it would be useful to implement it and see how it works. Note that we are adding countries and bank accounts, and we're going to measure all of them. The comparable interface is part of the Java library, and it requires implementing one method, a compare-to method. And that compare-to method is used to compare two objects. It is implemented by many of the classes in the Java API, and you might want to implement it in your classes to have access to the powerful Java API tools such as sorting. We'll look at that in just a moment. It's called on one object, so one object dot compare to will call the method, and it's passed a second object, so it's comparing this to some object that's passed in as a parameter, and it returns one of three values. If the calling object is less than the parameter object, it returns a negative number. If the calling object is greater than the parameter object, it returns a positive number, and if they are the same, it returns 0. When you override compare to, you should follow that model. It's very important to follow that model and not go rogue on your own path, because other programmers, when they see that you have implemented the compare to method, they will expect it to work in this way. So we can say public class bank account implements comparable, and then we can override that compare to method. Notice that we are downcasting other object to a bank account reference so that we can easily do the math, saying balance less than other.balance return -1, balance greater than other.balance return 1, otherwise they're equal, return 0. Notice that we don't have a third if statement, because if we did, we would get an error because all of our returns would be behind an if statement, and Java's not smart enough to figure out that at one point or another, one of them is going to be true. So Java just thinks, ooh, all the returns are behind an if statement. That means it's possible that we will never return anything. And so Java will complain. We can use compare to sort. Arrays.sort is a method inside the arrays class that allows us to sort objects, but those objects must implement the compare to method because the sort method inside the arrays class uses the compare to method. So anything that we pass it, any array that we pass it, must implement the comparable interface, and that will allow us to sort those objects in ascending order.